Welcome everyone to this presentation for Kinesiology 340 Measurement Evaluation. And in this presentation, I'll begin to provide you with a brief review of just the beginning of Chapter 2. But be sure you read and familiarize yourself with this information because it will be included on the next test. And we'll start by simply reviewing a few more statistical terms that you should know. Starting off with data, or data. You say tomato, I say tomato. And data is the results of any measurement that you complete. So if you've given an assessment and you get some results from that assessment, those results are your data. And generally, when we say data, we mean numerical results, but data can also be answers to a question or interview responses as well. Then we have variable, and this is a characteristic of something that can assume more than one value. Results of a test will differ from person to person, so a variable can be time on a mile run test, or it can be distance from performing the long jump. It can also be the number of push-ups performed on a fitness test, but anything can be a variable. Population is all the members of a specific group will make up your population. For example, if I wanted to include all kinesiology majors at FPU in a particular study, everyone who is a kinesiology major would make up my population. But because it's not likely that I can include everyone in my study, I have to take a sample or a small portion of that population. And that's what a sample is. A sample is basically a part of your target population or a subgroup of that population. And then there's also random sample. In a random sample, everyone from a population should have an equal chance of being selected for a particular study. And there are different ways of doing this, and the idea is to avoid selecting the individuals who are going to participate in your study because that would include a bias. And so the idea is to give everyone an equal opportunity to be selected to be part of your study so there is no bias. Then we have descriptive statistics. And descriptive statistics actually describe something. We use these to learn about a particular population and use information to explain something about that population. So descriptive statistics do exactly what they say. They describe. Then we have inferential statistics. And these infer. And another way of putting this could be to make an assumption. If you wanted to study the performance of all middle school students on the fitness tests, you would take a sample from that population, you would analyze the data that you have, and then generalize your opinion based on the sample you have. You'll make an inference or you'll infer some information based on the data that you have. And so inferential statistics will make an assumption. Now, the next thing that I want you to understand are scales of measurement. Now, there are 4 scales of measurement, and these are methods used to categorize data. And they're used differently to define numbers and variables that we obtain from results from data, and they help us to analyze statistics a little bit differently. Now, the 4 scales of measurement include the nominal, ordinal, interval, and ratio scale. So let's take a look at each one. The nominal scale of measurement is categorical in the sense that information is used to simply categorize something or someone. Now, you may have noticed on a survey or an application, they ask for your gender. This is a nominal scale of measurement, whether you're male or female. Another form of the nominal scale of measurement is your level of education. Some forms or documents may ask for the level of education you have, elementary school, middle school, high school, college, and these are just simply ways to categorize someone. Another scale of measurement is the ordinal scale. And this is basically a rank order of data. For example, if you're timing your students in the mile, you may note which students came in first, which ones came in second, third, and so on. Now, you're not actually concerned with the time or how much faster one student was over another. You're simply ranking them in a list from first to last. And another type of ordinal scale is how schools rank student performance. So students can perform below basic, at basic, proficient, or advanced. And we don't know how much better one student is over another. We just simply use this to categorize and rank them. The third scale of measurement is the interval scale. And within the interval scale, numbers represent equal units between measurement. And this scale is made up of things such as dates, months of the year, and temperature. Now, there is no true 0 point with an interval scale. For example, if it is 0 degrees Fahrenheit outside, it doesn't mean it's the absence of any temperature at all. It just simply means it's 0 degrees. And this is different from the next scale of measurement, which is the ratio scale, which includes a true 0 point. Now, the ratio scale is very similar to the interval scale in that The numbers represent equal units between measurements, such as height, weight, time. And the difference is, like I mentioned before, that there is a true 0 point. And a distance of 0 on a jump test means just that. There's no distance. A person didn't jump. And this is what makes the difference between the ratio scale and the interval scale. So be sure you know these scales and the differences between them, because this is likely to show up again on a test sometime. Now, many of you should be familiar with the measures of central tendency, and these are the basics of all statistical analysis, including the mean, which is the average of a set of scores, the median, which is the exact middle number in a set of scores, and the mode, which is the number that occurs most frequently. And if we were to look at the results of a 100-meter run test of about 18 students, we can begin to analyze the results by calculating the mean, median, and mode, the measures of central tendency. And they're called this because they represent the central area of the set of scores and data. And we'll take a look at that a little bit more and understand that when we look at the bell-shaped curve. So looking at the list of about 18 students, we calculate the mean as 11.3, which is the average of the set of scores. 11 for the median, which we get by multiplying 50% times the number of scores we have, which gives us the 9th score. And since we have our scores in order, we count to the 9th score and we see that that's 11. Now, if we didn't rank or put our scores in a list, we wouldn't be able to get the true median. Then we have 11 for the mode because it's the number that occurs most often. And there will be times when your data set does not include a mode, so don't worry if you don't have one. Now, another thing to familiarize yourself with is what we call a normal distribution. And what this basically suggests is that the distribution of any set of scores that you have is considered normal. In other words, there is an equal distribution of those scores. And we'll take a look at it in an example in just a minute. If we were to graph a set of scores, there would be or should be a symmetrical distribution around the vertical axis. And this is graphically represented by what we call the bell-shaped curve. Now, on a graph or a chart, the largest number of scores can generally be found right in the middle of that curve. And looking at this bell-shaped curve, we can see how frequently different scores occur in a population. Now, all of the measures of central tendency will be found at that vertical axis as well. So let's look at an example. Here we have a bell-shaped curve. And if we were to plot, for example, the 30 students, let's say we have the results of their test, we can see how the scores are distributed. So on the horizontal axis, we list the results of our assessment or our test. And in this case, we'll list the scores received by the students. And on the vertical axis, we list the results or how many times those scores have actually occurred, with the lowest on the bottom and increasing as we move upward. So as we plot our scores on the graph, we can see that 5 students scored 88 on the test. And there were 3 students that scored 87, 3 students that scored 89, and 3 students that scored 90, and so on and so on. As we take a look at this, although it's not a perfect distribution, we can see how it almost conforms to what we call the bell-shaped curve. And of course, all of your data will not look like this, but when we discuss a normal distribution, it is assumed that this is what we're referring to, that the scores will balance out and have an equal number on each side, including a high point in the middle. Now, your data can provide you with different types of distribution, creating different types of curves. And you should know these other distribution curves as well, because they may show up on a test. Now, if you have a group with similar ability, you may form what we call a leptokurtic curve. And this means that the majority of your scores are in the center, and very few students scored low or high or on the outskirts of that. Most of them are right around that average. You may also find that you have a wide range of scores, forming a more flat appearing graph. And this is called a platykurtic curve. And this means that your group has more varied results, making it more flat, more spread out. It's also possible to have what we call a bimodal curve. And this is when you have 2 high points or 2 modes in your data set or your list of scores. And then there's the skewed positive curve. And when your scores are clustered at the lower end of the chart, this means that the performance is extremely poor, or the assessment tool was poorly developed or too difficult for the group. On the other end of this, we have the skewed negative curve. And this is when the scores are clustered at the higher end of the chart. And this can tell you that either you have an excellent group of students who completed the test or your test was too easy. It can also mean that you're just an excellent teacher if these are your test results. So familiarize yourself with these different types of curves so you can begin to understand the distribution of scores and see how this can be used to start to analyze the data that you have. Now, there is an assignment for you to complete to demonstrate your understanding of this information within Moodle. So I've posted this document. It's titled Assignment Number 1. So print this document out, finish it, complete it, and you have to bring this to our next class meeting because there's some information that you may not be able to type on this document. But you have to bring this to next class to receive not only credit for attendance and participation for this missed course, but also for the assignment itself. If you have any questions, please feel free to contact me. Take care.